really quickly in this video, we're going to talk about how to dilate polygons on the Cartesian plane. Okay, so we're not going to worry about the CQ at all in this video. All we're really going to talk about is just like what I said, dilation on the Cartesian plane. So to dilate on the Cartesian plane, right, dilation on the Cartesian plane, all it entails is multiplying the vertices by the scalar. Okay? All it implies is multiplying the vertices by the scalar. And of course, we know a scalar is some number k such that typically it's going to be some natural number. And I mean, okay, I shouldn't say a natural number. It's going to be a rational number. It's going to be a rational number, and k is always going to be greater than 0, we'll say. Okay? And that's me being really particular, but it's not that important for this video. So here we see a triangle, right? And let's say I want to dilate it by a scalar of k equals 2, right? Well, let's be a little more ambitious. Let's say k equals 5. Why not? Okay, so I'm going to do exactly what I say right here. Multiply the vertices by the scalar. Well, each vertex, right, has an ordered pair that we see here, namely x and y. So all we're literally going to do is multiply each of these numbers in every ordered pair of each vertex by our scalar of 5, and we see that we're going to get 5 times larger, quote unquote, right? So 5 times 0, still 0. 5 times 1, 5. So this vertex, we're going to call it A2, is going to be at 5 times 0 is 0, 5 times 1 is 5, at 0 by 5. And you can already guess what's going to happen here to B. Okay, so 5 times 1, 5. 5 times negative 1, negative 5. So B2 is going to be at 5 by negative 5. And likewise is going to happen, if you haven't figured it out, to give us C2. Okay, so C2 is going to be at negative 5 by negative 5. And if we connect here, okay, we see we're going to get a much larger triangle. Okay, this much larger triangle is going to look something like that, right? Our base, we see, well, if we're going from 5 to 5, our base would be 10, right? And our height, we're going from negative 5 here to positive 5. Okay, so that is also going to be 10. Okay, so if we look at the area of a triangle, we know that that's base times height divided by 2, right? So 10 times 10 divided by 2, that would be 100 over 2, 50 square units, okay? Well, what was it before we dilated, right? We see our base is 2 and our height is still 2. Okay, so our base is 2, and that's not our base. Our height is 2, and our base is going to be 2 as well. Okay, so we do the same math. 2 times 2 is 4 divided by 2, right? And that is going to give us 2 square units. Okay, so pretty minuscule there, right? So we see we have a drastic increase in the area. Even though the dimensions didn't increase by so much, our dimensions increased by a factor of 5, but our area increased by a factor of 25. Okay, and if you want to ever delve into why that is even further, we can 100% do that. Okay, so now let's do something a little bit interesting here. And this makes me wish I would have dilated by a scalar that wasn't an odd number. But let's say, and you know what, screw it. I'll go ahead and just draw a new one. So let's say I had another triangle. And I'll start with blue this time. No, I won't. I'll start with green. let's say I had a larger triangle. Okay, so we're at 0 by 6 this time. This is going to be vertex A1. And we're going to be at 6 by negative 6. Okay, so 6 by negative 6 would be right here. Okay, that's going to be vertex B2. Negative 6 by negative 6, that's going to be C2. Okay, and if I go ahead and just El Conecto here, and this was supposed to end up being a shorter video, but not quite working out that way. But it is what it is. What are you going to do? Okay, so now let's say I dilated by a scalar of 1/3. Well, what's going to happen this time? Well, because K is less than 1, however, still greater than 0, namely a fraction like 1/3, I'm going to have a decrease in area now. So when I go ahead and multiply my vertices, so 1/3 times 0 is 0, 1/3 times 6 is 2, 0 by 2 is where my A2 is going to be at. Okay, likewise here with B2, I'm going to end up with 2 by negative 2. Okay, and C2 is going to end up being negative 2 by negative 2. And I mean, you can already see it. We've got a huge decrease in area, right? Our dimensions decreased by a factor of 1/3, right? We shrank by 1/3, but our area decreased substantially more. Okay, so if we did an area calculation now, uh, our base here would be 12, and likewise so at our height. So we would end up with an area of the triangle being 144 divided by 2, which is going to give us 72 square units, right? And if we check and see what we got on the smaller triangle here in blue, right? So our base now is 4 across, and likewise so is our height. So base times height would be 16 over 2. We get a very meager area of 8 square units now. So we had, again, a substantial decrease by a factor of 1/9 in area. And you may make the connection, well, 9 is 3 squared. Earlier, 25 is 5 squared, and so on. Not going to divvy too much into that. But like I say, if you want to know anything extra about this, obviously come and see me. So that does it for this video. Dilation is a very simple concept. Again, all we're doing to dilate on the Cartesian plane at least is multiplying the vertices by our scalar. Okay, and you'll always hear me refer to that scalar using the number K or letter K.